the window with a mullion will look. So now we have learned uh, three types of profiles. Okay, first is frame, which resembles capital letter L, then a mullion, which resembles capital letter T, and third one is glazing bead, that will depend on the thickness of the glass. Now let's see what profiles are used in a casement window. That is an openable window. Okay. First frame, the frame is same. Okay. The same frame that we're using in a fixed window, we can use the same frame in a openable casement window, the L frame. Okay. So it's the same frame. Okay. As I've told you, it could be of any brand. The dimensions could be different. The chambers could be different, but the basic shape will always resemble capital letter L. Now, the second profile which is used in a casement openable window is sash. Okay, the sash which is opening either outside or inside. And we do not use same sash for both the windows. We use different sash for outside opening window and different sash for inside opening window. And the only reason why we do this, because we always want that our glazing bead should be inside. So the outside opening sash, it resembles capital letter T, and the inside opening sash, it resembles capital letter Z. As you can see, here we are having three casement outside opening sash from three different brands, and all of them, the internal designs are different, the chambers are different, the wall thicknesses are different, the dimensions are different, but at the end, all three of them resembles capital letter T. Now let's see the structure of a casement window. Just consider this is a wall, okay? This is the opening where we are going to fix our casement outside opening window. This is the inside, that means this is the house, and this is the exterior, that this is the outside. So this is how we will place our frame, okay? The frame will be placed like this. Wherever, because this is an outside opening window, that means the sash will open outside. So when the sash will open outside, so the smaller side will come wherever the sash is going to open. So this is outside opening window, the sash will be opening here. So we will keep the frame, we will place the frame like that so that this smaller side will come where the sash is going to open. So first we have our frame. Of course, we are going to have our frame reinforcement, our frame gasket. This is our sash. Okay, this is our T sash, outside opening sash, sash reinforcement. Then there is, if you remember yesterday when I was explaining about casement windows, and I told you that there are two gaskets, one in frame and one in sash, because of which we get 100% sealing. So these are those two gaskets. Okay, one is here in the frame and one is here in the sash. So when this sash locks completely, then this things, it gives you perfect sealing because nothing could enter from here till here. Okay, so these are the two gaskets which are giving 100% sealing to your casement windows. So we had our frame reinforcement, sash reinforcement, frame gasket, sash gasket. We have our external glazing gasket. We have our glass, our glazing bead, and then our internal glazing gasket, which is fixed in the glazing bead. So this is the structure of a outside opening casement window. So this sash, it is going to open outside this way. This is the reason we place the smaller side of frame wherever the sash is going to open. Okay. So if we will see it from top to bottom, the cross section of a casement outside opening window, then it will look like this. This is the frame, this is the sash, and the sash will open like this. Now let's come to inside opening sash. So inside opening sash, it resembles capital letter Z. Now let's see the structure. So, okay, this is again, this is the inside, this is the outside. As you can notice, this time we have placed the frame in opposite way. Now the smaller side is towards the inside because this time the sash is going to open inside. So that's why we have placed the frame such that this smaller side of the frame falls inside. Okay. So we are using the same frame that we have used in our fixed window also, in our outside opening casement window also. So this is our L frame, our frame reinforcement, the frame gasket, our Z sash, okay. Sash reinforcement, we have our sash gasket, we have external glazing gasket, our glass, our glazing bead, and our internal glazing gasket. So now this way our sash is going to open inside. So now here we are comparing inside opening and outside opening window. Okay. So firstly, as you can see that the frames are placed in opposite ways in both the windows. Here is our inside opening sash. Here is our outside opening sash. Okay. So now as you can see, there are two windows here, right? So now in the left side, I'm having fixed, and in the right side, I'm having an openable sash. So here it is fixed, here it is fixed, okay? But this sash, it is opening outside, right? And this sash, it is opening inside. Now let's compare the profiles which are being used in both the windows. In both the windows, we are going to use casement frame, the same casement frame, the L1. In the outside opening sash, we are going to use the T sash, and in the inside, we are going to use the Z sash. Now one more profile which is being used in these windows are the mullions, okay? These mullions. So frame we are having L, इसमें हमारा we are using T sash, इसमें L frame and Z sash. And now if we come to the mullion, then with the T sash, we are using Z mullion. And when we are using Z sash, we are using T mullion. And the only reason why we are using them, because we want that our own all glazing should come inside. In glazing bead, both of them we can use the same glazing bead depending on the glass. If you're using the same glass, then we can use same glazing bead in both the windows. Now you can ask me that this T sash and T mullion, both of them looks same. But no, there is slight difference. Let me tell you what. As you can see, it is profile A. Okay, we have its T sash and it is T mullion. So as you can see, there is a little notch here. Okay, this is called the groove. Okay, so the sash profile will have a groove, whereas mullion will be two straight lines. There would be no groove in the mullion profile. If you look at profile B, as you can see, the sash has a groove and the mullion, both sides are straight. Then we have a profile C here also, as you can see, there is a groove and here both the lines are straight. Okay. So how you will get to know it is a sash or a mullion? The profile which has a groove would be a sash profile, and the profile which is straight from both the sides would be a mullion. Similarly, now if we'll compare the Z sash and Z mullion, in all three profiles, as you can see, sash has groove and mullion profiles are straight. Why? I mean, what is the reason that we do have this groove in the sash profile? Because in sash profile, in the sash we fix a spag. Okay, a spag is the hardware which is used for multi-point locking in casement windows and of course in the slidings also. So to fix this spag, this groove are mentioned. Okay, I mean in these grooves we fix this spag, and also there are special type of hinges which are used in UPVC windows which are called friction hinges. Okay, so these friction hinges are also fixed in these grooves. So this is the reason there is groove in the sash profile. And of course, we don't need to fix any hardware in the mullion. That's why we don't need any groove in the mullion. Okay, so now the question time. Which letter does a UPVC casement frame resembles? Please open the chat box and type the answers, please. Okay, Mr. Ankit Khanna, Ms. Praveen, Vikas, Subhadeep, Ankit Malhotra, Ms. Pooja, Kancha, Abhilash. Okay, everyone is telling it's C. And yes, the correct answer is C. Our casement frame resembles capital letter L. So the next question is, which letter does an outside opening casement sash resembles? Outside opening casement sash. Sanket ka naam se Praveen, Subhati, Pooja, Deepak, Vikas, Kancha, Krishna, Bilash, Nishit, Mr. Vikas, Bansal. Okay, everybody is telling B and correct. An outside opening casement window sash resembles capital letter T. Okay, which of them is a mullion, A or B? Okay, Subhadeep, Abhilash, Karan, Krishna Joshi, Vikas Bansal, Nishit, Pooja, Praveen. Everybody is telling it's B, and yes, it is B because a sash has a groove and mullion doesn't have a groove. Okay, which is a casement frame profile? Frame profile. Okay, Ankit ji, Karan, Nishitesh, Vikas, Brahmanyan, Pooja, everybody is saying it's C, yes. Okay, which is a sash profile, A or B? Yeah, everyone is telling it's A, and it is A because uh, A has groove and B doesn't have a groove. So B is a mullion and A is a out, which is a outside opening sash. Outside opening sash. Okay. In starting, I got a few A's, but now everybody's typing B. Abhilash, Krishna, Joshi, Nishit. Everyone is telling B, and it is B. Okay. So now let's come to casement door profiles. So as if you remember yesterday also I told you that casement windows and casement doors are almost same. Okay. The only difference is the sash profile, and of course the reinforcement will change and the hardware. Okay. Otherwise the functioning and everything is same. So in casement door, we have a frame. The same frame could be used in a fixed window, in a casement window, as well as in casement door, the L frame. It is the same frame, okay? So I'm not repeating it once again, that all the brands will have a similar. And then we have, similarly, as I've told you, that in casement windows, the outside opening sash resembles capital letter T. So similarly, as you can see, it also resembles capital letter T, and we have a groove in it. The only difference is casement window outside opening sash, it is smaller, and the door sash, it is bigger. And here also structure is also same. We will have our frame exactly like our casement window. We have a door sash, the T sash, and then we have our glass here, our glazing gasket. And similarly, as if you can compare it with the casement openable window, also openable window, here also we have these two gaskets, okay? One in frame and one in sash, which is giving it 100% sealing. So this way it will be opening outside. Now if we'll come to inside opening door sash, it will also resemble capital letter Z with a groove. The only difference is casement window sash is smaller and casement door sash is bigger. So here is the structure. We have our frame, then our sash. There are two gaskets between the frame and the sash. Then we have our external glazing gasket, our glass, our glazing bead, and the internal glazing gasket. Okay. So this way our door is going to open inside. Similarly, it is same one that we saw in the case of casement window when we have one fixed window and casement sash. Similarly, here we are having top fixed, okay, and then we are having a casement door below. So here the frame would be same for both of them. So as you can see, it is opening outside. So we will have a T sash here. It is opening inside. So we will have a Z sash here. And if you remember from the casement window session, then the mullion with T, we will use a Z mullion, and with Z sash, we're going to use a T mullion. And glazing bead, it could be same if same glass is being used. Here we are comparing outside opening casement window and a casement door. So as you can see, frame, it's same, and then sash is different. Okay, frame is same, then here the difference is the sash, it is smaller, it is bigger, and of course if sash is different, then its reinforcement is also changing. Okay, here is a reinforcement is different shape and smaller, and here the reinforcement is bigger, and then glazing bead is also same. Okay, because the glazing bead will depend on the thickness of the glass, okay, not on the profile. Now here we are comparing inside opening casement window and inside opening casement door. As you can see, frames are same, other things are same, only the sash is different. Here the sash is smaller and here the sash is bigger. Now we'll see glazing bead, single glazing bead. When the glass is thinner, we use bigger glazing bead. Just a second, excuse me, I'll be back in this. See, on the left side, we are using a thinner glass. So we are using this single glazing bead. And here we are using a double glass. So we are using a smaller bead, which is called a double bead. Okay. So which is a outside opening door sash profile? It's A or B? Okay. Mainly people are answering A, but a few have answered B also. But no, it is A because this A is a door sash profile and B is a window. Both of them are outside opening, but it is a door sash profile and it is a window sash profile. The bigger one is the door sash and the smaller one is window sash profile. Okay, both of them are going to open outside, but now let me just show you once. As you can see here, na, see This is the window sash. Okay, this is smaller, and this is door sash. It is also T. It is also T, but the only difference between the window sash and door sash is much bigger and window sash is smaller. Okay. So now if you'll see, as you can see, it is a window sash. It is smaller and bigger one is the door sash. Okay. So now for this question, you have to say true or false. Okay. The same frame can be used in a fixed window, openable casement window, and a casement door. This statement is true or false. Okay, Mr. Karan Shah, Krishna Joshi, Vikas Bansal, Mr. Ankit Khanna, Deepak Kumar. Everyone is saying A. That is true. Yes, it is true because we can use the same profile in all the three window types. That is a fixed, a casement openable window, and a casement openable door. And in fact, we can use the same in tilt and turn also and slide and fold also. Okay, now let's come to sliding profiles. So as we were using L-shaped frame in this casement windows and fixed windows, so in case of sliding windows or doors, okay, mainly we have three types of frames. Okay, one is 2 track, one is 3 track, and other one is 2.5 tracks. Actually, nowadays the 4 tracks are also available, but these are the majorly used tracks: 2 track, 3 track, and 2.5 track. I think you can easily recognize. Okay, there are 2 legs. That's why we're calling a 2 track. There are 3 legs which are equal. That's why we're calling a 3 track. And here, as you can see, 2 tracks. 2 legs are completely they're equal, but the third one is little smaller. Okay, that's why we are calling it a 2.5 track. Now, sash panel. Sash, we're talking about the panel in which we are fixing the glass. So, in sash panel, majorly would be a window sash or a door sash. Actually, in window sash also there are many size of sashes available. Very small series is also there. A little bigger one is also there. So we can subcategorize the window sash, and there's a mega sash also, which is a bigger door sash. So there could be many subcategories, but mainly we will categorize it into window sash and door sash. Okay. Now, if we will come to mesh panel, as I've told you yesterday, so the third panel in which we are fixing the mesh, the bug mesh, so that the insects doesn't come in. So it is called the mesh panel. So in this, we can either use window sash or door sash to fix the mesh panel, or we can use the screen sash. Okay. So the screen sash can be only fixed, can be only done with this smaller track of this 2.5 track frame. Okay, we can't use the screen sash in 3 track frame or 2 track frame. The smaller screen sash, it can be only used on the smaller track of the 2.5 track frame. The only purpose of the screen sash is to fix the mesh. Okay, we can't fix a glass here. So it is very smaller section, lighter section, and it is just used to fix the mesh, and that too it could be only fixed in this smaller track of the 2.5 track frame. Okay, because in the window or door sash you can either fix glass also, or you can fix the mesh, but in the screen sash you can only fix the mesh, and it can only move on this smaller track. Then we have this interlock is a profile which is fixed here and here. Okay, wherever two sashes meets in the center. Okay, we will just in I think next the third or fourth slide we will see how the interlock exactly works. Okay, so it basically fills the gap between the two sashes so that no insect or air or anything comes from that gap between the two sashes. How it exactly works, we'll see very soon. Then we have glazing bead. The way we were using glazing bead to fix the glasses in a casement or a fixed window or a door. Similarly, we use glazing bead to fix the glass in a sliding window or door. The shape of the glazing bead used in casement system and sliding system are entirely different. But here also majorly we use single bead and double bead, and there could be more beads also. Depend in different brands, there are different types of beads used depending on the glass thickness. So as we can see, the major type of profiles which we are using in a sliding are firstly frame, which could be 2 track, 3 track, 2.5 track. Then a glass panels, which could be window sash or door sash. Then mesh panels, which could be window sash, door sash, or screen sash in case of 2.5 track frame. Then we are using interlocks to seal the gap, fill in the gap between the two sashes. And then the glazing bead, which is used to fix the glasses depending on the thickness of glass. Then we have our sliding frame profile. Here we are looking at a 2 track frame. Okay, this is a 2 track frame. As you can see, there are 2 legs, so it is a 2 track frame. And one thing I think which you could notice is there is a slant. Okay, there is a little tilt, there's a little slant, and why the slant is there? Because in a sliding frame somehow the water could of course come inside. So this way, because here we always do our drainage holes, water slots. So this way, whatever water will come, it will get deposited here, and then through our water slot system we can move them outside. So if this is a frame, the position of the frame would be, this would be outside, wherever the slope is directing. Okay, it would be the outside, and the other side is the inside. Similarly, here we have a 3 track frame having we are having 3 legs, so we are having a 3 track frame. So I think now you would be getting that this way the water will go, so this will be the outside and this will be the inside. And in case of this frame, the slope is here, so this will be the outside and this will be the inside. So it is a 2.5 track frame. Here, as you can see, the third leg is smaller, and as well as the gap, this gap between these 2 legs, it is smaller in case of the 2.5, the third smaller leg of the 2.5 track frame, because in this, the third smaller leg, the smaller screen sash will come and it won't be needing much space. So that's why the space is smaller as compared to this space. So in some profiles, there is one more provision, that is to fix an additional track. For example, a 2 track slider is already fixed, okay, somewhere, and then a person calls you and asks you to fix the mesh, okay, bug mesh. But how you will be able to fix a bug mesh, to have a sliding mesh panel? You will be needing an additional track for that, to move the mesh panel in that track. So in that case, you can fix an additional track on the already which is the window which is present, and then you can install your bug mesh panel on this additional track. Not all profiles have this, I think. Few profiles do have additional tracks. And in case somebody is not having an additional track and still somebody needs a mesh panel, then what you could do, you could cut your 2 track panel and then fix it on the existing window. And then that way it can work as a 3 track window. Now let's come to window sash. Okay, window sash, it resembles small letter H. This is a door sash. As you can see, both the shape of both the sashes is resembling small letter H, but the only difference is window sash is smaller and door sash is bigger. It is a screen sash. It is that sash, the bug mesh sash, which I was talking to you about. Okay, I will just answer the queries at the last. Okay, about this additional track I've gotten query, I'll resolve it in at the last. Okay, so here we are talking about the window and door sash profiles. And this is the screen sash, the smaller sash in which we fix the bug screen and it moves on the smaller leg of the 2.5 track. Okay. So now here you can compare a window sash and a door sash. It is smaller and it is bigger. And in fact, there are more sashes available. Maybe in window sash, one more smaller sash could be there. In the door sash, again, a mega sash or a bigger sash. So there are many types of, if we bifurcated, it could be, because nowadays every profile is having so many bifurcations, so many series and so many options. But majorly we'll distributing it in a window sash and door sash. So if we will see, it is our 2-track sliding window. This is our 2-track frame. Then here are our 2 sliding sashes. And then here is a glazing bead. There is a small error in this picture as I don't, let me see if anybody could get what is the mistake in this picture. Okay, please. Let's see if anybody could guess what's wrong in this picture. Recently, I told you something while I was telling you about frames, 2-track frame and 3-track frame introduction. That time I told you something, and yep, so that is a mistake here. So if somebody can guess what's the mistake in this picture. Right. Okay. So Mr. Karan Shah is telling that the glazing bead is outside. Yeah. Fine. Yeah. Or you can tell that we have. But if I am telling that this is inside, okay, so the glazing bead is correct. Okay. If I am telling it is inside, but the placement of the frame is wrong. Okay. The slope should be towards the outside. No, glazing is inside because I have told this is the inside, this is outside. Yeah. So the frame placement is wrong. The frame placement, the slope should be outside. Okay. Slope wrong. Correct. So here we are having a 2-track sliding window and a 2-track sliding door. This is with mesh. So here we are having 3. Okay. So what happens when we are having one more mesh? So this is both the panels in a window and door we were having glasses. Okay. 2-track, 2-panel door or window. Here we have given one more track for the mesh. So now we have 3-track, 3-panel window in which 2 panels are of glass and 1 panel is of mesh. And here we are having 2.5 track. So we don't give 2.5 track with sliding door because the screen sash profile is very light and very small. So we won't suggest to use a screen sash profile for a door. Okay. With for a certain height only up to 4 feet, 4.55 feet, we will go for a screen sash. Beyond that, we will take window sash or door sash only. Okay. So screen sash we are using for very small windows. Here as you can see, glazing bead, it is a double bead. For double glass, the bead is very small, and for single glass, bead is bigger. But if you remember, then the shape of the glazing bead is entirely different from the shape of the glazing bead we were using in the casement window. What is the reason? Because this area, this is different in a casement frame or sash profile, and in a sliding sash profile. So now let's see the structure of a sliding system. Here is our one sash, inside sash, we're having glass, we're having the glazing bead, okay. Then there, about this sash, we're having the sash, the glass, the glazing bead. So as you can see, now let me tell you about the interlock which I was talking about, the profile which is used to seal the gap between the two sashes. So as you can see, it actually happens na, when you will install your sashes in both the tracks. So there is a gap between the two sashes. Just imagine right now you are looking at your window from the top. Okay, you have cut a section and then you are looking at your sliding window from the top. So you can easily see that there would be a gap between the two sashes, and then all insects, uh, sound of course, dust, if anything could enter from this gap. So to seal this gap, we use the profile called interlock. So like this, it is fixed in one sash, and then it is fixed in another sash. So as you can see, in one sash it's fixed here, and in one sash it's fixed here. So this way it is filling and locking the gap between both the sashes. So now nothing can enter from the gap between the sashes. Okay, so which is a three-track frame? Who will tell me? Okay, Abhilash, Krishna Joshi, Mr. Karan, Vikas Bansal, Praveen. Okay, so everybody is telling that it is C, correct? It is C. Because in D, as you can see, the third leg is smaller, so it is a 2.5 track. But in C, all the three legs are of same size, so it is three track. Yeah. So tilt and turn profiles. I think if you remember from our last session that I told you that tilt and turn profiles are exactly same as that of a inside opening casement window. The only difference is in the hardware. So same, where you're going to use the L-shape frame and the Z shape inside opening sash in a tilt and turn window. So the placement is exactly same as that of a casement inside opening window. Yeah. So here, if you can see, it is the hardware which is used in a tilt and turn window. Okay, because of this hardware only, it is functioning as inside opening, side hung window, as well as a bottom hung window. So as you can see here, this handle, okay. So right now it is in closed position, okay. And when you will move it here, then it will function as an inside opening side hung window. And when you will bring it at the top, it will function as a bottom hung window. And when you will close it again and bring it here, then it will be locked. So now another profile which is used is the coupling profile. So we have seen two types of things. Okay, we have seen the Boolean. Okay, what Boolean is doing? Boolean is dividing your frame or your profile anything in two parts. So as you can see, there is one frame, right? Then you place a Boolean, then you place a glass, you fix your bead and you fix the glass, and then you place another glass and you fix your glass with the help of your glazing bead. Okay, so this is the Boolean. What Boolean is doing? It is dividing your frame into two parts. Now, what coupling is doing? Coupling. What does couple means? Couple means to join. Okay, so Boolean is dividing your frame into two parts, whereas coupling is joining two different windows. Okay, here you have one window, then you have a coupling, and then you have another window. So this way you are joining two windows with the help of a coupling. So when we can use mullion and coupling. For smaller windows, we will go with mullions, okay? But for bigger windows, we will go with coupling. Why we will go with a mullion in the smaller windows? Just imagine there is a small window, okay? It's like 3 feet by 4 feet, and you need a division somehow. And what if you will give it with a coupling? Firstly, it will increase the cost. उसका cost बढ़ जाएगा because of the all those extra profiles which is being used and extra reinforcement which is being used. And secondly, as you can see, when we use coupling now, all this accumulates, okay, this frame and this coupling. So in a smaller window, this thing will look very bad, okay, so much profile all together. So for smaller windows, we go with mullions, okay, for the looks as well as for the cost. But in bigger windows, we go with couplings. Why? Firstly, we can't have a glass beyond a certain size. Secondly, for the strength, okay, if we use only mullions for a very big window, then it will not be so strong, and it will shake, okay. In a case of winds and high wind load, it will be shaking. So for its strength purpose and for it's easy in carrying and for the glass thing, we use couplings for bigger windows. Now let's see a few types of couplings. There are many. I mean, huge range of couplings, and each company also have their own range of couplings. But here we are talking about in broad aspects, what are the main couplings? Okay. So firstly, we have our edge coupling. Edge coupling could be smaller and bigger. Edge coupling we will use for smaller windows, and bigger edge coupling we will be using in bigger windows. So here there are two windows. You can see the front view here. Okay, this is the window one. Then you have a coupling. Then you have a window two. Okay, so this is joining two windows in a straight line. That is 180 degrees. Now, if we will look at the same window from the top view. So it is the edge coupling. Here is window one. We will screw it, and here is window two. So this is how they will be joined in 180 degree. Now for bigger windows, we will be using bigger edge coupling, and this is how they will look when we will have a top view. There are other very small profiles also, small couplings also, which are used to join windows in a straight line 180 degrees. Now the second coupling is a corner coupling or 90-degree coupling. It joins two windows at the angle of 90 degree. As you can see in this picture, we are having two windows, window one and window two. Now, if we will have the top view, then how it will look? It is our corner coupling. It is our window one, and then here is our window two. So this is how they are fixed, and this angle which we are getting between the two windows is a 90 degree. Now our third type of coupling is, it's called bay coupling. It gives you an angle of 135 degrees. So it is joining our two windows at the angle of 135 degrees. As you can see in this picture, there are three. I'll answer queries at the end. Okay. Yep. So here, as you can see, there are three windows. Window one, window two, window three. And if we will have a top view from here, then window one is here, window two is straight, and then window three is again at the 135 degree angle. So here you are getting an angle of 135 degrees, and here you are getting an angle of 135 degrees. So this window which is like this. It's called a bay window. Now the fourth coupling, it's called a bay pole coupling. It has two parts. One is bay pole cover and second one is bay pole adapter. So this coupling, we can fix the window at any angle starting from 90 degree to 230 degree. So it could, the angle could vary from 90, smallest is 90 degree and the largest is 230 degree. So this way there is this bay pole and then we can adjust the adapter on the bay pole depending on the angle we require at the site. So as you can see here, we are having two windows, window 1 and 2, and this is the angle. I think it's approximately, it will be about 120 degrees. And here it is window 1, it is window 2 and window 3. So you can clearly see that the angle here is different and here angle is different. So we can adjust the adapter on the bay pole depending on the angle we require. So when we make a door with a fixed, okay, so there are two options. Either we can give it with a coupling. So in that case, what will happen? We will make the entire door first. We will keep the coupling, and then we will fix an entire fixed window. Okay, so here we are having two different systems. The casement door, it's made entirely different. Then we put a coupling, and then we fix the fixed window on top. And second option is we make single frame, then we place the mullion, then we place our door sash, and then we fix our glass on the top. Okay. So when this top fixed part is not so big, okay, up till maybe 1.5 or 2 feet, we can go with the mullion. But if it's big, then we will go with the coupling for the strength purpose, because when the part is huge and if you're giving with the mullion, and as you know that the door is used very much, okay, so it won't be so strong and it will shake a lot when you will open it and close it. In the case of coupling, it will be much stronger and it won't shake much. So that's why if the top part is bigger, then we will go with the coupling, not with the mullion. And in the side, when we are fixing it, we can't give it mullion. We will give it with coupling only. In the slidings, when it is fixed, we always give it with coupling, because as you can see, the frame profile of casement system and sliding system is entirely different. But nowadays, some few companies are making this different type of sliding profiles in which they are giving an option, okay, for keeping it fixed. But normally, what we do whenever we will give a fixed window, we give it with couplings. No couplings. We don't fix in wall. Couplings are fixed in frame only. Okay. Couplings are fixed in frame. They are not fixed in walls. They are we need to screw it in the frame only. They are not fixed in walls. They are part of your window only. Which of the following is a bay pole coupling? Who will answer me this? Bay pole coupling. Okay, Mr. Ankit Abhilash, Praveen, Vikas, everybody is telling D. I've got less question, I mean less answers. How many participants? I have got 18 participants, okay, and I've got just few answers. Okay, Deepak, Mr. Ankit. Let me just count how many people are answering. Okay, so out of 18, okay, one is me. So 70 out of 70 people, 8 have answered. And other people haven't answered. Please do answer. It looks nice now because then you don't get bored. Otherwise, so handling a long session is quite boring. Okay. So everybody has told D. That's correct answer. It is a dipole coupling, which is joining your windows at any angle between 90 degrees to 230 degrees. Okay. Next one to have answered only. But if somebody hasn't seen, then which is a Bay coupling? Bay coupling. Okay, this time I'm asking what Bay coupling. Karan Shah, Vikas Bansal, Mr. Bilal, Mr. Ankit, Pooja, Mr. Ankit Malhotra, Rahul, Subhadeep, Krishna Joshi. Okay, I think everybody knows it. So it's C, which is giving us a coupling at an angle of 135 degrees. Corner coupling, which is a corner coupling. Okay, Karan Shah, Subhadeep, Ablash, Vikas Bansal, Praveen, Kamala, Shazad, Rahul, Ankit Malhotra, everybody is telling it's B. Yes, it is B because it is the coupling which is giving us joining the window at 90 degrees. So which of the following is a H coupling? Okay, I've already answered. Start answering. Good. Right. It's Rahul, Pramila, Prameen, Shazad, Karan, Pooja. Okay. So we are joining. I mean, it's the H coupling. Correct answer. Okay. So tell me in this window, which coupling is used. Okay, and we can use two couplings actually. So you have to tell me which two couplings we can use. Okay, two couplings. Okay, I've got answer from Subhadeep, Ankit, Praveen, Shizad, Abhilash. Okay, normally everybody has saying A or C. Yes, correct answer is A or C because of course the angle is okay. B also, yeah. If you are going for coupling for this also, yes, we can go for B. If you are going for the straight coupling, and for this we can use A or C. For 90 degrees we can use A or C, and for the straight coupling, of course, we can use B. Correct. Very good. For this window, okay, which are the profiles which can be used? Okay, Subhadeep Ghosh, Karan, Ankit Khanna, Pramila. Okay, I've got interesting answers in this. Okay, and somebody has typed all also. Okay, let me see the all option is correct or not. Mostly people have typed A and D. Okay, let's see. A, yes, we can use it. D, of course, paper, we can use it, right? And then B also, I mean, if actually there is no coupling, okay? So, so we are going with A and D because as you can see, it is one straight window, okay? There is no coupling here for the 180 degree. So we will be needing coupling at this place and this place. And as it is a bay window, the angle will be 135 degrees. So yes, we can use A or we can use D. Okay, so which coupling for this window? Okay, please look at it carefully. So Shubhadeep, Ankit, Karan Shah, Ankit Malhotra, Rahul, Pramila, Veen, Shazad Bilash. Okay. Everybody is telling. Okay, Shazad is telling A and B both. Okay. Let me see. Most of you have typed A, and yes, the correct answer is A, because as you can see, there is no fixed angle. Okay. We can't define it as 90 degree or 180 degrees or 135 degrees. So the angle is changing. Okay. So that's why the answer is A. Okay. Only A. We can't, because we don't need any 180-degree coupling here. We don't need a corner coupling here. We don't need a 135-degree coupling here. So the answer is A. So my almost today's topics are over. I mean, it was quick. It was damn quick. Okay. So I'm highly impressed with you guys. You're a very quick learner. So just type me in the chat box. Okay, should we end the session or I should start a new topic? Let's go with the majority of votes. We have got 20 minutes more. You want to go for glass? Just type. What will type? Mm, just type more or no. Okay, yeah, more. Maybe we will go with one more. I mean, we'll cover glass topic also. And if you will type no, then we'll just have some questions and then we'll close it. Yeah, Mr. Ankit Karan Shah is telling more. Good, good, good. Okay. Then let's start our glass session. Okay, just give me 2 minutes. Let me just start. Share my screen, the new slides. And roller is must or not? I mean, roller as in, of course, if you're, there are two types of things. Okay. Firstly, if you're giving it with two track, and then you're giving one more fixed panel, of course you won't be giving any roller in the fixed one, because you don't need to move that sash, so you won't be giving the roller in the fixed sash. Okay. And the other thing which I was talking about, because I haven't seen that, but I have heard that there are some new profiles which are coming. I mean, the cheaper profiles which are giving an option where you can put somehow a mullion, and then you can give a fixed window with the sliding windows. But I think hardly a few companies are doing that, and that too some, I think, Chinese companies are giving an option. Not any good company that I've heard of is giving option. Okay. But yes, if you're giving a fix, you can't give a roller on that. Okay. So screen is invisible. I'm not getting the point. Acha, my screen. Okay, I thought screen says. Okay, fine. Right now time is, it's 4:40. Okay, so whatever will come complete in 20 minutes, we'll complete it later. We rest we'll cover tomorrow, because I've got one more class at 6 p.m. Okay. So glass, what's main role of glass? Okay, firstly, glass, it is improving the status of the building, the look from the outside, and it is also used inside. And the main use of glass is to let the light enter and stop the ventilation, and so that we can have a look outside. Okay, so main roles of glasses are, it's increasing the looks of the building, the view which we can see outside from inside, and it's eliminate the airflow, energy efficiency. That means it stops the heat from coming from outside to inside, so that when we are using our ACs and all, so there is minimum heat loss and minimum heat entry. Sound insulation, of course, glass plays a major role in sound insulation, that is stopping of sound. Properties of glass: it is transparent, elastic, it's strong, it's workable, it's transparent. The transparency, we all know that the glass is transparent and we can see through it, and the light could enter inside it. Elasticity, what does elasticity means? It means that if we will apply some pressure on the glass, then till a level the glass will bend, okay, and then it will come to its original form. Okay, but it's applicable only till a certain force. Okay, and if you will cross that force, if you will apply more pressure than the glass could bear, then it will break. Okay, till that pressure, what will happen? It will bend a little and it will come to its original form. strength. So normally a glass could handle a strength of 275, 27.5 to 50 megapascals. After that, it will break. Till this point, it can have the force and it will come to its original shape. If you will apply a force more than this, it will break. Workability, we all know that glass can be molded in any shape and form. Transmittance, it transmits the light. Recyclable, it could be recycled 100%. Okay, and वैसे तो I mean normally what we do, I mean whatever things are recycled, somehow they degraded. I mean with every recycling their quality degrades, but glass is the only material which doesn't degrades. Okay, and 95% of the raw material of the main glass, it is recycled glass. Okay, right now we are having a very quick run of how the glass is made. We don't need to go very deep in this. Okay, so firstly here at this point all the raw material has been mixed and it is put in the furnace where the temperature of the furnace is about 1500 degrees Celsius. Okay, it's very hot. And then and what happens now when let me tell you one thing. Okay, so there is a glass which is called a tinted glass. That glass has that glass has color inside. If you have seen those blue glasses, green glasses which have color inside, those are tinted glasses. So if we need to make tinted glasses, so here in the first process only, while they are mixing all these raw material, you need to mix that specific minerals. Okay, there are different minerals for different colors. So whatever colors glass need to be made, that specific mineral needs to be mixed at the first stage only. And then slowly the material starts flowing and then it comes to this float bath. Here the temperature of the glass keeps on reducing, and then when the glass enters, it's at 1500 degrees, and the glass when exits, it's about 650 degrees Celsius. So when it is leaving from the float bath, it is like a thick ribbon, solid ribbon structure. It's not completely solid, it's like a ribbon structure. And then here only, okay, so tinted glass, we know that when we make tinted glass, we need to mix the minerals at the first stage only. But there is one more glass called reflective glass. If you have seen those glasses in sun, if you will look at them, they will appear as a mirror. Okay, because all the light which fall on them, it reflects back. Mostly in hospitals nowadays, and if you go to Gurgaon, all buildings, those shiny buildings, those are all reflective glasses. So for reflective glasses, they need to apply a metal oxide coating. So that coating is applied here at the float stage, okay, on the surface of the glass. And then slowly, this keeps on cooling down, and you see that there are no bubbles and cracks and all. And then finally, the glass is out, and then it is cut to order, and then it is sent to the required factories. So now three main factors, okay, which are on which we measure the performance of glass is the U value, the shading coefficient, the relative heat gain, and the visible light transmittance. So what is the U value? Okay, so U value is nothing but the process of heat transfer. Okay, just imagine there is a piece of metal. Okay, what happens if you will put fire, I mean a source of fire on the one end, then slowly entire metal will start getting heated, right? Because that is conduction. The heat will flow. Similarly, what is U value? The glass. Okay, the sun is falling on the outside. Then slowly this entire glass will get heated, and then this heat will be transferred inside. So the heat which is transferring to the surface, okay, to the conduction, it is the U value. So the lower the U value of a glass, it is better. That means lower heat is flowing through conduction. And then, so two ways, okay, there are two ways through which the heat is flowing. First, of course, first the glass is getting heated, then it is reflecting, radiating the heat inside, and secondly, direct sunlight is bringing some heat. So that is called shading coefficient. Okay, So that the direct solar heat gain which is coming from the sun is the uh, shading coefficient. And third is visible light. We need more and more light, of course. So what is a high performance glass? A high performance glass is which has a lower U value. That means lower heat transmittance through conduction, lower shading coefficient. That means lower heat transfer, direct sun heat transfer. And thirdly, which is high in visible light. So we need lower heat, but we need good amount of light. So now let's see the types of glasses. Firstly, based on its strength. Okay, first is annealed glass. इसको हम लोग बोलते हैं normally कच्चा glass. Okay, so the first glass की sheet that comes out of the plant is the annealed glass. It is not so strong, and when it breaks into sharp edges. And we never recommend an annealed glass for a first floor and above windows, okay, because it could break and then it could fall and it could hurt somebody. And we also don't recommend any glass for bigger windows because it is firstly it is not so strong. Secondly, when it will break, it could hurt someone because it breaks into sharp edges. And then second is heat strengthened glass. Okay, what happens? We take annealed glass, we heat it to a degree of to 1200 degrees up to a temperature 1200 degrees, and then we'll cool it instantly. So what happens after that? This glass becomes stronger. So it is 2 times stronger than an annealed glass. Then a toughened glass, a annealed glass, again it is heated at a very high temperature of about 1200 degrees. Then it is cooled down even more quickly than a heat strengthened glass. So it is 4 times stronger than a annealed glass. And when it breaks, it doesn't break in sharp edges. It breaks in crystallized form. So it doesn't hurt anybody. So the strength of annealed glass is Fx, then strength of heat strengthened glass is 2x, and the strength of toughened glass is 4x. But one thing which is with toughened glass is we cannot we cannot change its shape. So there is a basic sheet of float glass. We cut it in the desired size, and then the toughening process take place. And once the glass is toughened, we can't change its shape. If by mistake you have ordered a bigger glass for a smaller window, you can't change its shape. For annealed glass, you can do it, but for a toughened glass, you can't change. So which of this glass is strongest and safest? Okay, so normally everybody is telling C. Yes, it is C. Okay, so which of the glass breaks into sharp edged pieces? It's annealed glass, it's heat strengthened glass, or it's toughened glass. So it's A and B both. Both of them will break in sharp edges. Okay, which glass is this? A or B? Correct. It is an annealed glass. Which glass is this? Okay, everybody is correct. It is a toughened glass. Okay. So now let's come on the division based on color. So on color, if we'll come, we can divide it into 4 basic types: clear, reflective, tinted, and frosted. Clear glass, as we know, it is transparent, and as it is transparent, so it allows maximum amount of heat and sunlight to enter. Nowadays, we do have extra clear also, which do not have this green tint in it. Next one is reflective glass. So we have a metal oxide coating on this glass. So what happens whenever this sunlight falls on it, it reflects back. So it is reflecting back major quantity of heat and light. And it also reflects the harmful UV and infrared rays, and it allows some natural light to pass through. So that's what we need, right? We don't need heat to enter. We don't need harmful UV rays to enter, and we need only visible light to enter. If we come to tinted glass, as I've told you, to make this glass, we are using different types of minerals to give different colors to the glass. And there is a difference, okay, between the reflective glass. Reflective glass, what they are doing, they are reflecting back major amount of light and heat, right, and UV rays also. But as you can see on tinted glass, there is no coating layer, okay, and they are normally dark in color. So what they do, they are not reflecting the heat and light, they are absorbing it, okay, especially dark shades tinted glass, they absorb the heat. And of course, so they are not letting the light to transfer, but they are at the same time they are absorbing the heat. So one thing which is absorbing the heat, when it will get heated, it will radiate the heat inside. So if you will well, we would like to go for an option where you want minimum amount of heat to transfer, then it's better that you go for a reflective glass because they're reflecting it back. Whereas what tinted glass are doing, they are absorbing it and then they are radiating the heat inside. Now there are photochromatic glasses also. They are little expensive, but they're used. So I think you have seen it in Ray-Ban glasses, right? When you go out in the sun, they turn out to be dark, and when it's dark, then the glasses turn light, depending on the amount of sunlight. The frosted glass mostly used in washrooms and office cabins. So there this translucent layer is there through which you can't see through. There are many processes through which you can get a frosted glass, just like sandblasting, acid deadening, vinyl film or even canned frosted glass trays are also there. So which of these glass have metallic oxide coating? Okay, Karan Shah, Subhadeep, Pramila, Virendra, everybody is saying it's C, right? It is C because this metal oxide coating, it reflects back all the excessive sun glare, heat and UV rays. Okay. So which of these glasses contains minerals that give the color to the glass? Okay, everybody is typing answer A and it is right. It is tinted glass. Which of these glass reflects maximum amount of light? I think you can tell that from the name. I don't know what is anterior glass. Sorry. We do have Mr. Ankit here, who is a glass specialist, so we can ask him what is an anterior glass. Okay, Ankit ji, it is a type of reflective glass. Okay, Ankit ji is telling it is a type of reflective glass. Okay, it is a Saint Gobain brand. Thank you, Ankit ji, for telling that. Okay, and Ankit ji also typed that that the temperature is not 1200 degrees. So because I have read it I won't name the brand in whose manual I read that. So what do you say? At what 750 you are saying? Okay, but I read it in a very popular brand. It's not Saint Gobain. In their manual I read it was 1200. Yeah. So which of these glasses allow least amount of light to enter? Okay, so here we are talking about, yes, reflective glass can be toughened. Ankit J is saying it's never B. Okay, then let me confirm because I'm not a good person to talk about glass. Yeah, if we think about the process as we have seen the process also, na, that at the flow stage they are applying the layer, right? The metal oxide layer, and then what's happening in toughening, they are heating it and then cooling it. Of course, I mean, maybe when they will heat it and cool it, then the metal oxide layer will get ruined. This is the reason it can't be toughened, but I'm not sure about this. But Mr. Ankit is telling that reflective glass can't be toughened as he's from a glass industry. So uh, okay, so identify which glass is this. Can be toughened. I mean, now it can be toughened. Okay, so now people are telling it can be toughened. Acha, temperature can be 750 degree. Okay, yeah, yeah, yeah. Okay, so it can be toughened, and but temperature can't be more than 750 degrees. Okay. Yes, it is a tinted glass because as you can see, it is dark in color, but still we can see what's inside. And which glass is this? Right, it is a reflective glass because as you can see, वो पूरा का पूरा reflect back हो रहा है. Okay, so we are getting a few things that it can't go beyond 750. So let me confirm from other sources and then I'll confirm you. We can go beyond that or not. Okay, so now we have last 5 minutes left. Actually, it's almost five, and I need and I have another engagement at 6 p.m. So I have to get ready for that. So we will call off for today, and this structure thing we will be studying tomorrow, and then we will cover hardware tomorrow. Quickly, we will cover this glass topic. Is this last topic in the last session, and then we will cover the hardware tomorrow. And any questions if you have, you could please just note it down. Then we'll discuss it. And firstly, we'll discuss the questions, and then we will start the session. So for today, we are calling it off. So bye everyone. Have a nice evening. Catch you tomorrow in the hardware session.